Well, hello. So, I wanted to give you all an overview of the US customary system. Sometimes when you look things up on it, you may even see the English customary system. So, the way things happened was that someone decided, hey, I don't want to measure things the way that you all are measuring. It had to do with probably mostly political things and also getting away from the church. When the Church of England became they started their own, separating from the Catholics and whatnot. I won't get too much into the history. But also, during that time period, we had a lot of French mathematicians, and it's actually something that went on for a couple of centuries and has probably been put away from a lot of people's minds. But they decided, why are we always going after everything in terms of tens? Hmm. I don't know. It doesn't make much sense to keep going after tens. But anyway, we do. What if instead we change things to be out of 12? Well, why 12? Well, how many times do you have to cut things in half? A lot, or it's pretty easy, right? It's easy to recognize, okay? So you can do that fairly easily. You can cut things in half fairly easily, and you can represent that. Well, you can do that with 10 as well, right? We can cut things in half, right? 10 cut in half, you get fives, okay? Is it really easy to understand how things look in groups of five? Probably, yeah. You probably can recognize that very well just because you deal with it a lot. Like when you look at your fingers, you can group things of five very well. If you go even higher, it gets a little difficult. Um, so we can do split things in half. We can do twos, groups of twos. We can do groups of five kind of easily because five times two equals 10. Okay, you may even be able to group 10 kind of easily because you can do five and five real quick, and then you can do those groups of 10, two very quickly, so you get 10. You can do groups of one very easily. Most people can. But they realize that, hey, most people in society, they need to know more than just that. They don't even really need to know five. We look at things more so in different versions of two. So two, four, eight. I didn't say six. I said eight because when you double four, you get eight. 16, 30 seconds. All that. That's fine. We can still do that with a system of 10. But people also need to understand thirds, right? When you're cooking, you use a third of things. When you have these tablespoons and teaspoons, tablespoons is pick three of those and you get the ounce. Like you get all these different measurements that and tools that we use that we need to kind of understand three. Well, if we need to understand two and we need to understand three, what can we do to keep this simple? So we need a number that has factors of two and three. Oh, let's go with six. Okay, six sounds good. That sounds real good. Um, is there an issue with six? No, there's not an issue with six. Yeah, no, there's not. But we use fourths a lot. Oh, we can just take half twice. You'll be good. You'll be good. That's fourths. Well, let's have something that actually has four as a factor, just to make it a little easier for people. Okay, so it has two, three, and four as a factor. Oh, 12 does. That's the smallest we can come up with, so let's use 12. Because anything after that, we just double it. We can get 24, and we can triple it, because we still have 3 as a factor here. We get 36. So we can get every other number that we need of it. So let's use 12. And so if we start off with a basis of 12, we're looking at things in terms of twos, threes, fours, 6, 8, and then 12. Okay, that covers a lot, right? Because if I want to cut thirds and thirds, I can do that because I can kind of visualize that a little better because I'm used to thirds, and so I can do ninths. Okay, can't do sevens that well. That's okay. No one cares about sevens. uh, but everything else is covered. So for 7 and 11, when we look at that, all right. So let's come up with our own system and let's push this out here. And we're even going to try to get people to change the number system. We're not going to use 10 anymore. We're going to use 12. Well, that last part, that didn't go over too well. But everything else did. And they were able to use this. And then when people came over from England to settle in the United States in their colonies, you all probably have seen that in history. They took that with them because they already learned that. So they had this English customary system that became the U.S. customary system because England eventually was like, let's go back to what everyone else is doing over here because, that makes sense. Let's all be unified, blah, blah, blah. And the U.S. kept this because, hey, this still makes sense to us and this is fairly easy to use. In fact, a lot of countries around the world use what is now called the U.S. customary system, or you can call it just the customary system, because it's easier for them to do when they're looking at different measurements of things. So it's kind of interesting. But when we have the U.S. customary system measurements, we generally like to look at one, two, three, four, 5 different things. Measuring distance, So how far from one point to another. And in regards to distance, we'll say we want to know how much is covered going from here to here, and then going from here to here. So this whole area, we want to say how much is covered by that area. So we actually call that measurement area. Well, let's then say we want to know from here to here, up to here. So we want to know how much this area is covered if it's spaced out this way. So we want to know that total amount of space. Well, there we get volume. Okay. Well, so we have volume. And there's something else that's very similar to volume. Well, we just want to know how much. That was good. How much liquid an object can hold. So that's capacity, how much something can hold versus how much space it covers up. Those two are very connected to each other. In fact, they are pretty much the same. However, we can use different units for that because volume is still measured based off taking this distance by this distance by this distance. Capacity would just be measured fully with the liquid. And then we also have weight. Weight is the amount of force an object exerts onto something. So in our case, we usually look at it on the planet Earth. How much force is exerted on the planet Earth by that? So that's a very general definition of weight. A lot of people just say, I get on the scale, it's my number of pounds. Well, good. So in each of these, we have certain units that we use. With distance, area, and volume, you'll see things in terms of inches, or inches squared, or inches cubed. You'll see in terms of feet, in terms of yards, in terms of miles, and we have other special things that are in between there. But those are the popular ones. In terms of capacity, we'll be looking at how much something can hold. So we'll look at ounces, we'll look at gallons, we'll look at cups, pints, quarts. You can even go as far as tablespoon and teaspoon. We won't look at that, but if you understand the basis of converting between them, you'll be able to do that and use those more in the kitchen for those of you that cook. And then with weight, we'll be looking at ounces, pounds, and tons. Now there's one more thing up here. Actually, there's two, but we'll be looking at this one thing here. It's called compound. So compound measurements. Whenever you have a compound, you combine things together. That's what this measurement is about. It's about combining these together. So say I want to know what's the capacity per inch. Say if I want to know, like on this thing here, I want to know how many ounces per inch as I move up this bottle. That's very useful. I have another bottle here that you won't be able to really tell what goes on here, but on this bottle, there are different line markers based off of how far distance you travel, and it then tells you what's the capacity there. That's kind of cool. Have you ever seen anything like that? Yeah, probably have a measuring cup. Measuring cup will be doing the same thing. It uses compound units. The distance that you travel tells you what the capacity is. I may even want to know how much force or how much weight is exerted per square area, per square foot, per square inch. These are things that people use a lot more in construction, but you can also see that when you look at pressure in your tires. That's what pressure in your tire is. It's a force over a certain area. It is a compound between weight and area. That PSI stands for pounds per square inch. So something to look at. So I have something else written up here, time. And that's written up here because we won't look at time specifically, but you do need to realize that it is still used in the US customary system. Time is used in both systems of measurement that we'll look at. We have seconds, and you can convert those seconds into smaller units when we look at the other unit of measurement. We have minutes, you can go to hours, and you can go to days. From days, of course, you can go to weeks if you want, or you can just go to months instead, or maybe you want to go to years, or you want to go to centuries or millennia, or